When we look at a stellar nursery like the Orion Nebula, the scale is difficult to process. These glowing clouds of hydrogen gas stretch across light years, appearing frozen in deep space. Yet inside this stillness, matter is actually accelerating at a massive scale. Inside these clouds, gravity acts as an unseen force, relentlessly dragging material toward a central point. Dense pockets of gas and dust begin to swirl, forced inward by their own mounting weight. As thousands of tons of material are shoved into a tighter space, internal friction skyrockets. The temperature inside this collapsing pocket rises from near absolute zero to millions of degrees. Left unchecked, gravity would crush this cloud into a single, lightless point. The star only emerges because the rising pressure eventually triggers a physical reaction capable of pushing back against that weight. At the absolute center of this collapsing cloud, where the crushing pressure reaches its peak, a dense core forms, the protostar. Deep inside that core, the weight of gravity becomes so extreme that individual hydrogen atoms have nowhere left to go. The pressure forces them to violently smash into one another. This visualization shows the result: two hydrogen atoms slamming together and fusing into a heavier element. This process, nuclear fusion, releases a massive burst of outward-pushing energy with every collision. That energy forcefully pushes out against the falling gas. This brilliant light is the visible byproduct of a continuous subatomic explosion, successfully resisting gravity's crush. Once the outward pressure equals the inward pull, the collapse halts. The chaotic gas clears, leaving behind a mature star radiating in the vacuum and space. This diagram shows the mechanics of the truce. Blue arrows representing gravity pulling inward are balanced by red arrows showing fusion pushing outward, hydrostatic equilibrium. This stalemate keeps the surface steady, creating a stable environment where planets form and maintain predictable orbits. But this billion-year peace is finite. The outward push of fusion depends entirely on a limited supply of hydrogen fuel. Eventually, the star burns through its primary hydrogen reserves. The moment that fuel depletes, the outward pressure drops and the stalemate breaks. Gravity responds immediately. With less energy pushing out, the weight of the star crashes down, compressing the weakened core into a tighter space. This inward squeeze generates such extreme heat that it ignites dormant, volatile layers of gas outside the center. These new fires push outward with more force than the original fusion ever produced. The star swells into a massive red giant. Its surface boils with plasma, beginning a rapid expansion into space, vaporizing nearby planets in its path. The star expands into a distended version of its former self, the physical consequence of an engine finally running out of gas. The cosmic war ends when the last of the nuclear fuel is exhausted. The outward push of fusion stops entirely. Without internal support, millions of miles of stellar mass plummet straight toward the center. This catastrophic collapse occurs at a significant fraction of the speed of light. All that falling material slams into the dense core, triggering a colossal rebound. The resulting supernova creates a shockwave of fire and plasma that can momentarily outshine entire galaxies. For the heaviest stars, gravity's victory is total. The core is crushed into a single point, so dense that it traps its own light, forming a black hole. No matter how long a star shines, gravity wins the final battle, ripping the structure apart and leaving only debris behind. Looking at the aftermath, we see an expanse of space enriched by that destruction. The heat generated in those final